we're going to be learning machine learning from ChatGPT. Okay, I'm going to make a file called beginner.py over here, and we're going to try to understand what's going on here. So first of all, let's go from the very top. So I'm not going to talk as much in this video, but yeah. So first of all, as you can see, this is the roadmap that I got. As you can see, I have familiarity with these stuff, so this is fine. NumPy, pandas, matplotlib, the stuff that I'm familiar with, so it's not like completely zero. For this, you need to classify, so that's why you use classification algorithms, k-means, and this is for normal regression, decision trees, like algorithms, and frames. I have a few other notes here as well. Neural networks, CNNs, RNNs, transformers is like going through many different layers of like what it comes in the model, and then there's a lot of different layers which it gets passed through for encoding, and then it decodes it at the very end, right? Like this, see? So you receive the input, it sends it to many different encoders, and then it decodes the final output. So this is a very good definition of it, as you can see. So it's a pretty cool definition. So let's use this. I already have this node, so let's go ahead and let's keep. Okay, so GPT is like, I don't know what this stands for, but generative pre-trained transformer. Interesting. Alright, TensorFlow, I know about it, so I've done like a video on this. So some projects. Yeah, I'm gonna go in this path. This is just use usual LLMs. So yeah, let's go with this one first. So yeah, let's get started. So first of all, we do understand these stuff, right? To an extent. So let's go ahead and it's the usual week 2. So this is what you gotta learn on the second week, right? So anyways, let's go on to the practical project. That's what I want to get my hands on with, beginner. Okay, so this is the project that it proposed for the beginner level. So first of all, let's go ahead and install these packages real quick. So let's go on here and let's install this. I think I'm on the right path. Yeah, I'm on the right path. So as you can see, we have the read CSV file from this URL. So this is the Titanic CSV, and let's get the first 5. That's what we're doing here. So I'm going to explain as we do stuff. So it's going to print out, if I print, and if I run this, as you can see, it's going to print out the first 5. So 0 to 4 index, so the first 5. And we're going to explore this data like this as well. You can see that we can get more information like this. If you want, you can just give only the first 5, so the information about them, and if it's null, then show me the total, right? That's what we're doing here. And as you can see, we have all of them in order. So let me just run this real quick. As you can see, we have first print statement, second print statement. So let's leave an n at the end. So I'm going to do f string and say, oops, over there, n at the end, and we'll run this. As you can see, so this is the second one, which is this statement right here. So what we're going to do is we're going to try to understand the first one, which is this one, and we're getting the information about it, right? So from 0 to 11, so the first 10 items, we're getting the information about it. If it's null, add all of them together, I believe. Yeah. Right, okay, this is something of confusion here. So explore the data, so that's what we did with this, and that's what we have here, right? So we can in fact do this, and we can visualize with Seaborn. So I don't know why it's not opening. Oh, it's because I need to import. Let me just run this real quick. I don't know why it's not running, for example. Oh, well, oh, it's because I've imported it twice. It just keeps glitching out for some reason. Okay, well, I hope that fixes it. So what we're going to do is we're going to try to understand the aspect of SNS. Let me just run this real quick. Okay, so now we have this figure from Seaborn. So let's try to understand what's happening here. So of course we know that this is the x-axis. So that's the data frame. And then the, we haven't really divided this properly, right? Because we haven't divided the data axes properly. I don't think this is doing the job right. Okay, clean the data. So that's dropping all the like not filled values and filling them with you know, filling the not analyzed values with the mean in the place that you have the empty values. And same thing here with the mode's first index, first items. So for embarked, so I'm assuming this is x-axis, this is y-axis, and it drops these from the table. So interesting. Convert categories to dummies. Interesting. Okay, well, so then you train it, of course, with scalar. So it's a test, train test split. So it's 20%, and yeah, so 20% to testing, and the rest is training, of course. Random forest classification. You fit the model, and then you know, train the model just like that, right? So see the accuracy. You just print out the accuracy. You get a model out of it to share. So at the intermediate level, let's try to do some understanding here. So once again, the first 5 items, you can count the affiliate Twitter dataset. Interesting. So I'm going to download the Twitter dataset. I'm going to download this real quick. So let me just download it. Okay, well, so in the meantime, value count, and let me just download this. Download that. Okay, well, so there we go. Now I'm going to extract this real quick. Don't mind that. All right, so as you can see, we have the file. So what we're going to do is we're going to give this as the path to that one. So what we're going to do is we're going to give that as the path for this. So let's try to do, let's call it internet.py. And right here, we're going to give it this path. So it's tweets.csv file. So we're going to drag and drop this anyway. So we're going to call that. And if I print out the first file, it's because of the already open file. Okay, so let's say, for example, print df info. See what sort of information. Okay, so we have multiple different types of data. So we'll have to convert it into one, which I think is part of the next one. Okay, NLTK, what does that stand for? Right, okay, text pre-processing, interesting. Removing stop words, removing punctuation. Interesting. Lower casing, okay. Removing punctuation, tokenization, that's like getting words in terms of tokens, individual tokens. Lemmatization, what's that? A process in natural language processing that reduces words to their base or dictionary form. Interesting. There's an NLP that reduces words to their base or dictionary form. Interesting. Right. Okay. So it's like making the actual word, but like simplifying it pretty much. It's like simplifying the actual word. Yeah. Okay. Right. Okay. So you're supposed to simplify it. So word net limitizer. So that's what this is. Stop words. Okay. Stop words. Right. Okay. We're having an English lesson right now. Okay. Vectorize the text. Next features 5000. and you fit transform the data frame right here. And you also build the model finally, so 20% for the testing, rest for the training, 80%. Multinomial NB, that's the model we're using here. We're building the model with this. So the usual as before with the sklearn. So that we visualize the final conclusion. So now this is the expert level. Let's see what this does. So once again, we have two different types of data sets here. We convert it to one type. What's up, Eddie? So we have transformers, which is the model we're using here. And so we're getting the text to list. Okay, we're converting the text to list. And we're making them into embeddings. And from there, we're using CPU, CPU, FICE CPU, which I believe is a library for efficient similarity search and clustering of dense vectors. Interesting. What is this? This is super complex. FICE. A library for efficient quick similarity search and quick clustering of dense vectors. Interesting. Efficient similarity search and clustering of dense vectors. Right, okay. Interesting, okay. Well, we'll get a screenshot of this. Let's call it nice. Alright, so we have that, and we have the resume embeddings. So it's coming from over here. So let's keep this as reference, so that way it's easier. We just, okay, so we have the job resume embeddings right here. So shape 0, face index flat L2. We're using the NP array to get it into an array. So index is, I believe this is in flat, okay, well, create a FICE index, and then you add this as a, add resume embeddings onto it right here. And match jobs to resumes, 5, okay, so that's the, just try for 5 jobs. Where is it using K? Index search, interesting. So using 5, resume for job, right? Top 5 resumes for job, I plus 1, right? Alright, this is the iteration loop, right? So it's iterating through the job embeddings, I believe. Just try for, right? Just try for 3 jobs. So 0 to up to 3. So it's running through an index search loop. And it's doing this X amount of times. Every single time it will print this statement. And it would print out the resumes.ilog. Interesting. What's resumes.ilog? Where is resumes.ilog? I don't know where it is, but resumes.ilog, and it's getting this, right? This is just deploying the API and getting the structure working. So just the data, and it's looking for the job from the data and encoding the job text to get it in vectors. And from there, it's doing an index search through these job vectors, and it's getting DNI in the independent variables, and the top matches are the ones that are going to be sent to a list, and they will return the top matches. So this API, when you use this key, you should be able to get this data. So it's very interesting. Streamlit is pretty similar, I would say. Here's the job description. Okay. So this is like a front end, and best button, find best matches. So if you click on this button, right, this is the description, this is what the title says. If you click on this button, do this, right, encode job description as job vector, and convert that into an array, and do an index search, get DNI for I is 0th index position, right, markdown and write the right. Okay. Yeah, power resume matcher and job recommender. Interesting. I mean, embeddings is basically having, so for vector databases embeddings, the data must be converted to a list using okay. So when you're working with embeddings, you're supposed to convert it to a list. Interesting. Working with embeddings and vector databases, your data must be converted to numerical vectors. Those vectors must usually be in list or numpy array format. Right. Interesting. So vectors must be in a list. So that's the as you can see, this is encoding it, right? So this is the model we're using here, and right. So we're converting it to a list to get the vectors, and that's what we use in RAG, retrieval augmented generation. Retrieval augmented generation uses that. So for retrieval augmented generation, you need vector databases, right? So that's also called RAG. And for vector databases, you need to have, these stuff basically, like data with embeddings, and that needs to be in like a list format. So that's what it's saying here, right? Pinecone is one of the vector databases. The data must be converted to numerical vectors, embeddings, and those vectors must be usually in a list or numpy array format, right? So right here, as you can see, where is it? So as you can see, this is the normal format, right? So that's what happens when you can encode it, right? And this is the type, as you can see, and then you convert it to a list to get it as vector embeddings. See, numerical vectors. See, convert to numerical vectors. Boom. Interesting stuff. So text data, as you can see, we have resume data, right? Embeddings, you encode it and then you convert it to a list for vectors in embeddings, right? So this lets you iterate through the vectors in the embeddings in this scene. Okay, well, I don't think I asked that question properly. The variable embeddings becomes a 2D numpy array list of vectors. So it allows you to iterate through each vector on one per input text using the same variable name in a loop. So we have this, you encode this using texts. This is the model we're using here. And for the vectors in embeddings, you get this is the type, and this is the length, and this is the first 5 dimensions of this, and you convert it for JSON or vector DBUs. If you're going to store these, store and send these vectors, you convert them to regular Python lists. That's what we do here. Now a list full of lists, right? So these are the vector databases. Right, interesting. So let's go back up here. I want to take another look at what's going on here, just to sort of recall. So let's start with the beginner project. So this is a beginner edition. So first of all, this is just installing calling the file, getting the first 5, getting the information, and making sure. Let's see what this just is. Do question mark. Right. Okay. So let me grab this. Interesting. Returns a data frame of the same shape as df, but with true where value is nan, thing and false otherwise. When used the boolean data frame, true counts as 1, false as 0. Right. How many true values, missing values are there in each column? Right. Okay. So how many missing values are there in each column? Yeah, that's just. Right. Okay, well, in this case, we're going to try something else. Okay, let's go back to beginner. All right, so let's see what this. Okay, so let me just try again. So we have that part, and describe is just like describe what's in the data. This is just visualizing it using Seaborn. So we have the data frame, the usual stuff here, the count plot. Not too sure what this is, but box plot, right? So there's different ways of plotting the graphs, I believe. Data frame, yep. So you drop these columns right here, drop the data from these, and then you fill the empty values with the mean in each column and in the places where it's missing. And for embarked, you want to fill the empty columns with the mode at the 0th index. Kind of random, but have you ever used? Yes, I think I've used Comfy UI. It was like for a React project, I believe. I had like I have downloaded this, but I didn't. Yeah, I did download this, but I haven't like properly used this. I think I saw one of my friends generating like the, like a, what do you call those things again? Like a image generation model. Like he made one of these. That was like an image generation model. Stuff like this. Or text to video. It was pretty cool. It's like really nice. I haven't used this a lot, but I mean, I did install it. I'm pretty sure I have it. Yeah, there we go. So yeah, this is the best place for exploring models right here. All right, well, let's go ahead and get dummies, convert categories, numbers. Interesting. Columns, right? Training models. So this is using sklearn. Random state. Random forest classifier. Fit the model. Training. Accuracy. Classification report. Okay. Interesting. and you dump, you get the snip intermediate. Right, value counts. Interesting. What does this do? Right. Yeah, I have not. You can see the class distribution for before training a model. Okay, well, say ML. Let's grab this. Yeah, so let's say for example right here, I'm going to say for a Twitter data set. Okay, so okay. All right. Stop words in English. Lematizer. Okay, well, the usual text stuff. Right. Split the words. Iterate through the word if W not in stop words. Okay. This is just building the model. That's simple stuff. Visualizing. That's fine. Expert level. Or yep. Convert to one data type. Get the sentence transforms model. Model encode. Get it to a list before, just like before, because of the embeddings. And then install this CPU model. I'm not too sure what's happening here, but I'll have to refer to this again. On making the model, I mean the API endpoint, and then this front end. Right. So the confusing part that I have mainly is this part. What does this do? Alright, well, because I understand this part, right? Converting it to a list, that's what it does over here. So it encodes by converting it to a list. So that way it's easier for the embeddings. Because you need the, the embeddings to have it in a vector database, right? So for RAG, and you convert it to a string to keep it in the same data type consistency. So let's see what this is about. Search indexing, right? I think it's under search indexing. Vectorizes. Yep. Okay, let's see what this does. All right, so we have embeddings representing resumes, right? Find the top K most similar resumes for each job using FIs. Top K most similar, right? So I think it's like the semantic thing. Facebook AI similarity search is library for fast nearest neighbor search dimensional vector spaces. Right. Measure similarity between vectors. Performs an exact nearest. Right. Perform a search on the device index with this query vector. Index search returns distances from the query vector from the to the top k resumes. Smaller means closer. The top k resumes in the resume embedding exist. Interesting. I'm gonna go through this part again. I need to go through this again, like once more. Stop words. Word limitizer. I need to go through this exact chat a few more times. I think then I'll be able to like properly do this. I'll just keep going through this a few more times, then I'll try to do it practically, then I'll get the hang of it. Because I have like literally everything I need. I'm just gonna go through this slowly, in case you guys wanna take a snapshot or a recording of what's in this chat. Or perhaps I could even share this link on the chat right now. Give me a second. So that way it's easier, I think. It's more convenient. Let me share it in the chat real quick. Give me a second. Alright, let me just share it in the chat. You're gonna see Yapper in the chat right now. That's gonna be me. And that's the link to view this. So if you click on it, you should be able to see it. And yeah, so because I gotta do it a few more times as well. So if you guys want to follow along, you can see everything over here. And yeah, it's a lot to process at once. I need to take this slow and try to understand what's going on here. So yeah, thank you guys so much for coming by, Eddie. And yeah, I'm just gonna keep going through this on my own time outside of stream to get things right. And by tomorrow, hopefully, I'll be able to build my. I'm aiming for the beginner, the intermediate, and the senior project by tomorrow or within this week. If I can build all three of these, then should be all good. I mean, I understand up to the embeddings. I just convert it to a list and check for empty values if there's any. You know, you encode it into a list, and then where is it? You encode it into a list. This is just the usual. You encode it into a list. You use this phi CPU thing, which I need to look into. And once you have that, you call this index flathead. You just do this algorithm thingy, and then once that's done, you'll be able to search through it. And you just make an API endpoint. Just call these functions from here. Because that's part of this. Part of this. Call the API endpoint. So the search is actually part of index, which is part of this. So top matches, and yeah, this is what the endpoint does. You can never run in. That's not complex. Yeah. So we're gonna try to master these three projects, so that way we can move on with the rest. So vectors and embeddings. We convert it to a list when we need you know. I go through this on my own for some time, and then tomorrow hopefully we'll be able to build this. So my goal is to build this tomorrow at the same time. Build these projects practically. So that way by Tuesday I'll be God level at this. This is of course not that complex. It's just calling the right model here. That's the only thing that changes across all these. Just to give in the test size, this is just 20%. And getting the data frame. just calling a different model depending on the use case, and then just fitting it and, you know, predicting it. It's not complex. Well, this part is just visualizing it. This lematizer thing, I just don't understand it yet. I mean, it's like getting the words more simplified, right? Instead of saying acknowledgement, you could just call it acknowledge. That's like the simplest way I could explain it. So that's the model that's called here, and that's been used over here as well. You return that. Right. Mm. Filling the empty spots with the mean for the age in place. Plotting. Yeah, it's not difficult. Just gotta do it a few more times and then you should be fine. Getting it to one data type for consistency. You know, encoding it to a list. Right? Getting it to an array later on, as you can see. So I understand up to that point, but this is what I need to understand. Calling this from fies and using 5, using the index search through this right here. This is just the iteration pretty much. And this is just the resumes. This is the part that I need to understand. From there, it's just making an API endpoint and building a front end. Yeah, it should be fine. Should be able to do this by tomorrow. Hopefully by tomorrow at this time, we're going to do the same stream. And we're going to build this out practically. Even if it's, you know, horrible, it's fine. We'll build this out. This is just a linear regression, I would say. And, you know, you can just do stats.linegress and probably plot this x and y axis. Sentiment analysis, this is interesting. Risers. For this stage, you need the wait. Encoder, multiple different layers. Spits out the output from the decoder. Embeddings and right here. From the vector database, right? Generation from the LLM response. Look at that. So there's 2 models here, isn't it? The way I see it, wait. Yeah, I mean, encode the text and search to it. Top matches, as you can see, and you return them for the API endpoint. And this is the front end, of course. Yeah, so we'll do this tomorrow at the same time and try to understand how this works through the struggle. That's it, boys. Thank you so much for coming by. I know it was kind of boring.